Hello, thank you for the introduction. Let's see if I can share my screen. All right, hello everyone. My name is Thorsten and I'm a software engineer at Google. My talk today will be covering how the script component works, what the third-party wrappers are, and how we've been working with optimizing third-party loading in Next.js. To give you all some more context of what we do, I work in a team called Chrome Aurora, and our mission is to advance the web framework ecosystem by introducing better tooling and improved defaults to popular JavaScript frameworks and libraries. Our goal is to improve user experience across the web with special emphasis on performance. We've been collaborating with the Next.js team for years, and we share many objectives, including our mission to find utilities and automatic optimizations to enhance the developer and user experience of the framework. We helped ship multiple utilities in the past number of years, including Next Image Component, Next Font, Next Script, and our latest collaboration, Next Third Parties. For our talk today, we'll be focusing on Next Script and Next Third Parties. We'll be covering things like, what is a third party to start off with? What challenges do we face when using them? How to add a script with Next Script, and how Next Third Parties make our lives easier. We'll be using a common script example to see how we can add it efficiently to a Next.js application. So let's dive in. Wait, before we look at our example, let's clarify what a third-party resource is to start off with. The HTTP Web Almanac defines a third party as an entity outside of the primary site user relationship. You can think of a third-party resource as being sort of anything that involves aspects of the site that are not directly within the control of the site owner, but has been included with their approval. Third parties come in different shapes and sizes and are more than just analytics. Here are some examples. It can be anything from ads, analytics, of course, the content embeds, widgets, cookie consent forms, videos, and the list goes on and on. The third-party ecosystem is massive, and it enables developers to use these resources without having to reinvent common use cases. There are some gotchas, though, and it's important to realize that using third-party scripts can have performance implications. Data from the Chrome User Experience Report, or CRUX for short, shows that Next.js slides that load more third-party scripts have lower interaction to Next Paint and largest contentful paint pass rates. The correlation observed in this chart does not imply causation. However, local experiments provide additional evidence that third-party scripts significantly impact page performance. All right, now that we know what a third party is and what to look out for, let's see how we can use the script and third parties in the most performant way. The first challenge is to figure out how we can add a script to a Next.js application in the first place. So let's imagine you're getting a task with adding a script to your application, and the TPM was helpful enough to provide you with the code to drop into your HTML page. It seems simple at first, but there are so many questions like, should I add an index page to the public folder and just drop it in the code? You can just add it. Should I add it to each route or just one particular route? Do I need to add it to a certain component? Or am I doing it right? Or what if I need to kind of have multiple scripts that are kind of orchestrated? So a lot of questions, and really just getting a code snippet doesn't really give me the confidence that I can really add this to a Next.js application. For that reason, that I mentioned in a previous slide, we worked with the Next.js team to develop a script component. The purpose of the script component is to enable developers to add scripts to a Next.js application in an intuitive way. The goal was to expose a minimalistic API that gives developers flexibility to control how scripts get added and when they execute. So let's see if we can use this component to rework our initial script we got. The code to implement had two script tags, one with the source attribute and another with a script tag with some JavaScript in between. The first part we can already solve by just assigning the source as seen in the slide. For the second part, we have to dive just a little bit deeper into the script component. Let's take a look. The script component can be divided into two groups, depending on where they are coming from. We have external scripts, which are scripts that get loaded from an external source by adding a source attribute pointing to the resource. This can be either an absolute external URL, or it can be an internal path to a script in your public folder, for example. And we have inline scripts. These are scripts that can get added directly to the HTML document. The only requirement for inline scripts is that it needs an ID attribute, which is Next.js uses to track and optimize the script. It seems like for our use case, the inline script might be the best solution for our second script type. Remember, it was the script that had some code in between. This can be done by either placing JavaScript within the curly braces or by using the dangerously set in HTML property of the script component. Both options really do the same thing. It just depends how comfortable you feel with either one of them. Okay, so let's put it all together. Here's our simple component that we build. We call the custom script that uses the script component twice, one inline script and one external script. Comparing this to the initial script that we got, it seems like this has everything covered that in terms of code inclusion that we needed. Now we have to figure out where to place the component to ensure it all happens at the right time. For that to find out, again, we're going to look at the script component a little bit deeper. There are different types of scripts, depending on where we want to execute them. There are application scripts, which are scripts that load and execute in all of the routes. Basically, as soon as whatever page you go to in the application, it gets executed. We have layout scripts. The layout scripts are some that just execute for some routes or for a particular route. And of course, we have the page scripts, which load just for one single route. Scripts can get added to a Next.js application in different places depending on their needs. Wherever you add the script, though, Next.js ensures that the script only loads once. It's also important to call out that the script component supports both router options, the app router and the pages router. Some implementations differ. For example, the application scripts are added in different places depending what router you use. Safeguards are also implemented to ensure that scripts are compatible with the router that you choose. For example, Next.js ensures that developers don't inject scripts with the defer attribute in the app router, which doesn't really play nicely with the streaming IIRC. For our implementation, I decided to go with the application script together with the app router. This already looks great. We were able to use the script component twice for an external script and for an inline code. Additionally, we were able to use the custom component efficiently and add it for all our routes in our route layout component. Remember, I'm going to use a route layout component since I'm using the app router. All right, so we've got all the code. We now place it in the right spot. So let's see how we can further optimize our script and decide when the script should get loaded. The strategy property is an optional property, which lets you fine-tune the script's loading behavior. It gives Next.js instructions on when to load the script. This seems promising. Let's take a look at each strategy in more details to find out if any of them is helpful for us. The first one is before interactive. The before interactive strategy loads the script before any Next.js code and before page hydration occurs. Scripts with before interactive would always be injected into the head of the HTML document, regardless of where it's placed in the component. Since this loading strategy loads the script eagerly, it should only be used for the critical scripts. Hard to say. If you're using the app router, before interactive scripts must be placed inside the root layout. Otherwise, you would place it in a custom document component. Example for usage could be like a bot detector or cookie consent managers. The after interactive strategy loads the script early, but after some hydration on the page occurs. Scripts with after interactive can be placed inside any page or layout component and will only load when the page or group of pages are accessed by the user. This is also the default strategy if a strategy is not assigned by the developer. Common uses for this one could be tag managers or analytics. Seems to be a good fit, right? So let's look at the other options first, and then we decide if this is really the one to go with. Later load. The later load strategy loads the script later during browser idle time. Similar to after interactive, this script can be placed anywhere on any page or layout component. This strategy is best for low priority scripts since we can defer the loading until all resources on the page have been fetched. You can think of maybe chat support plugins or social media widgets. And the last strategy is probably also the most talked about, the worker strategy. Using the web worker strategy is probably the most talked about one that's available currently. It seems like a solid option since it allows us to offload the script from the main thread to the worker thread. There are some trade-offs, though, that you should be aware of before you opt into to use the worker strategy. The main two considerations are what type of router your app is using and what type of script you're thinking about using with this strategy. The worker strategy is best suited for scripts that are not UI intensive, meaning scripts that don't perform a large amount of DOM updates. Good candidates might be exactly a Google Tag Manager or Google Analytics, which are scripts that don't interact with the UI and lazily send events in the background. And also, the other thing to think about is that currently the app router is not supported with the worker strategy. All right, so for our script, I chose After Interactive. It's an important script, but it's not super critical. And that's why we're waiting a little bit before we're loading it, which gives the app time to initialize what it needs to do. And we're not trying to interfere with any kind of order how the scripts execute. We're also using the app router, which means that the worker strategy is not really recommended yet. So let's go with this one here, After Interactive. The last thing I want to do is, let's say after the script is loaded, I want to send an event or do something afterwards with it. So let's see if that is possible. Again, we're going to take a look what else the script has to offer. Executing additional code. Event handlers can be used to execute additional code after a certain event occurs. So they are available client-side and allows you to control the flow of the script execution inside your app. A few that are available is onload. So this one happens once the script is loaded. Onready runs after the script is loaded and every time the component mounts. And we have onError if the script fails to load. Onload does not work with Before Interactive. If you're using Before Interactive, you should be using onReady instead. So a couple things to keep in mind when you're combining the different options. Sweet. So we're able to add our script and control a bunch of execution details. So let's wrap it up and see what else we can do to simplify. Went a little bit too far. All right, so the script component is highly configurable and gives the developer flexibility to support the most common use cases. What combinations to use for a particular third party and deciding where to place the component can be difficult though. So how do you know what works best? For this purpose, we're going to meet Next third parties, a Next.js package that contains predefined components with the most optimal loading strategies applied and ready to use. No more guessing on how to integrate a third party. So let's see which ones are available. The Google Tag Manager is used by about 66% of Next.js sites, and it's the most used third-party script around. To add and instantiate Google Tag Manager, the only requirement is to add a GTM ID, and it just works. It also comes with a handy helper function to send events if that's needed for your app. Google Analytics is used by 52% of Next.js sites, and it's close to second in terms of usage. So for this one, the GA ID is the only property needed, and it's similar to Google Tag Manager that it also comes with a helper function to send events. Here's a little tip. If you're already using Google Tag Manager, you can configure Google Analytics directly with it. So rather than including Google Analytics and Google Tag Manager, just opt in to use the Google Tag Manager and use Google Analytics with that. Some fun ones, Google Map Embed. It's a simple plug-and-play component, and you just can add it to any page on your app. It uses a loading attribute, which allows us to lazy load the embed below default, which is a really nice performance optimization that comes out of the box with it. And it defers the loading of the map if the user didn't scroll to your map yet. And last but not least, the YouTube Embed component. It's also a simple plug and play. You can just add it anywhere on your page. This one, under the hood, it uses the light YouTube Embed component. It's a custom element, and it's used using the facade pattern. It basically displays a thumbnail of your video first, so it's just an image that you're displaying in the custom element. And once you interact with that, then we're actually loading the video embed. All right, so for the initial script, we're lucky, and Next third parties has a wrapper function that we can use to replace all the stuff that we wrote previously. And this looks pretty neat, and it's performant, and it's just one line with one property that we have to pass it. All right, so let's look at some of the magic that happens behind the scenes. So some third-party wrappers we are implemented using third-party capital. Third-party capital is a resource that consolidates best practices for loading popular third parties in a single place. The library currently supports both JavaScript and PHP and provides a framework-agnostic solution that promotes reusability. Think of it as a central source of truth in regards to best practices and loading strategies that any framework could use. So how does it work exactly? So let's take the YouTube Embed component for this example, which only really needs one video ID to be able to play a video and display. The Next.js component takes the required props and passes them along to an equivalent wrapper function of third-party capital. Third-party capital uses a utility function which uses the props and a JSON file to output an object with instructions. This object can contain HTML code, scripts, style sheets, depending on the third party that you're using. Next.js takes that object and feeds the instructions into a custom component that's called third-party script embed, which renders the result to the screen. For the user, you don't have to ever interact with the third-party script embed. You really just have to interact with the YouTube Embed component. So here's kind of a short example of the JSON file that the third-party capital uses under the hood. Take a look at the HTML element, and it's a very simple example on purpose. Once attributes are passed to the format data function, the JSON file gets converted to a custom element. Looking at the HTML key now, it's a simple string value with the custom-like YouTube Embed component and all attributes needed for this component to work. So in this case, it's really just the video ID and an optional play label. Next.js takes the HTML, scripts, and style sheets from the custom object and assigns the HTML values to the third-party script embed component. All scripts and style sheets get assigned to the script component, which is a child of the third-party script embed component. All this is abstracted away from the user to allow a simple interface to interact with. The goal of third-party capital is to deliver the most performant way to load a third-party script. Currently, the YouTube Embed component exported by Next third parties uses the light YouTube Embed, which is, when demonstrated in Hello World Next.js comparison, loads considerably faster than a regular iframe. Oh, on a quick side note, this also is is my teammate and also the tech lead in all the third-party efforts. So, as you can see, with a library that is very easy to integrate with and very easy to interact with, there are wins out of the box that can display a video extremely fast without much thinking about it. All right. With that said, that's it. I hope there was something in there for everyone. Next third parties is still under active development, and we're always looking for feedback from all of you. What works, what doesn't work, what you would like to see supported, anything you can think of, drop us a line, and we're happy to hear from you. All right, and that's it for me. Thank you so much.
All right, thank you so much. I believe, let's take a look. I didn't mean for you to go all the way away. I clicked too many buttons. Let's see. We do have a couple questions for you. Let's see, starting with, how can server-side rendering in Next.js impact the use and performance of third-party scripts?
That is a great question. It really depends when we need a script to execute. So it really depends. There are different strategies that we have, and that's really the strategy property that you can also read up more on the documentation. There are different strategies that allow us to decide when we want a script to render. It also depends. The script component is very flexible in purpose, so it also depends how you compose the usage together. For example, if your script is depending on some callback events, for example, those are just available client side. So it really depends what your needs are. A lot of scripts that we're working with, they are more focused on, most of them are not critical, where we can defer them to a later point when we want to load them in the application to defer and not to interfere with blocking the main thread while the Next.js application is instantiating itself. So it really depends. There are some scripts that actually get initialized and kind of prefetched beforehand with the server-side rendering, and then it gets loaded on the client side. So it really depends what the needs are from the script that you're using.
Thank you. Let's see. Can you discuss any tools or libraries that are particularly useful for debugging and monitoring third-party scripts performance in Next.js applications?
I'm probably a little bit old-fashioned. I like the Chrome Dev Tool panel. I use it quite a bit. There's, of course, you have Lighthouse as one tool to kind of go through it. You have the performance panel. It's very easy to work with. It's very easy to spot kind of like the large kind of fruits, the large hanging fruits or low hanging fruits, however you call it, what the saying is. It's easy to kind of find some easy wins for your site. To get better insights about performance of your application, you can use something like web page speed test. I forgot exactly the name of it. You can use that to really run some numbers. That's really a good starting point. A lot of our resources, how we kind of discuss or how we kind of look and debug or how we can really figure out where some scripts are kind of bugging down the performance is really using a lot of field data from the sites. So we're constantly pulling data from HTTP archive and go through that and can see how is the usage from different tools, how is the usage from different scripts, and what should we focus on when we're looking for performance gains.
Thank you. All right. Let's see. You showed the performance of the first render for the video player, but how does the performance compare when you actually try to play the video?
Once you interact, once you click on the video poster, it loads in the iframe, and then it's exactly the same thing. So then it depends on everything else whenever you play a video, network speed, etc. So it's the same thing. It's using a facade pattern. So it's really the first. It might be maybe depending if you are on a slow bandwidth, there might be a split second when you're loading the iframe at that point when you click on it. But overall, it still gives you the benefit of having your site be interactive faster and being able to interact with it and choose what you want to do.
Very cool. Thank you. And let's see. Is there future support for other libraries such as Intercom or Full Story?
Is this meant for Next.js or for third-party capital? It's hard for us to say. I'm working on the third-party capital part of it. So those are the third parties that are supported by our team. It really depends. We're open. Usually the way we decide what scripts should be added to it is really by seeing which scripts are used the most of the time, which are the most popular ones, and also which libraries could benefit from performance improvements.
Got it. And it looks like I have one more for you of what future trends do you see in the handling of third-party scripts in Next.js or similar frameworks?
It's an interesting question. I think I do like the facade pattern a lot. I like, for example, the way the YouTube component works, where we don't have to load the script right away. Of course, this kind of depends on what kind of third party it is, right? So it kind of goes more with scripts that are more visual with a lot of UI tied to it, where that works. I think workers are very, very exciting, and I would love to see that be supported in all the routers and be more stable. I can see that being the future, but we just don't know.
Fair enough. Well, wonderful. Thank you so much for joining us today. We greatly appreciate it.
Thank you so much for having me.